I'm Sari Custer, and this is Sari on Science for Arizona Science Center. And today we have a very special treat as part of our Apollo 11 50th anniversary celebration. I actually have one of our amazing, well, you've been a volunteer with us for a long time, Everett Greenli,
right.
Who actually worked on the Apollo mission as a Boeing engineer. So,
Right.
Hi, Everett.
Hi.
All right. So, can you tell us more about your job? What did you do working on the Apollo program?
Well, excuse me, I started out in 1963 with the Boeing company in New Orleans. They had the contract to build the first stage. The building that we worked in was an old sugar beet factory, and then it was converted in World War II to a tank plant, and went vacant until the early 60s when Saturn Apollo program, NASA purchased the facility.
Wow. Okay, so that seems really interesting. What is it that drew you to being an engineer at that time?
Well, my job, excuse me, my job was as an industrial engineer was called a scheduler. And my job was using, in our day, technology called the PERT scheduling system. We used punch cards.
A little different than now.
Right, we had 20,000 punch cards in my small area that we kept track of. So we had to handwrite all of the information onto documents, onto sheets of paper, and then people transferred that into the computer, and we'd once a week have to go to the computer center and look for all of the errors and fix all of the errors.
So really quickly too, because some people may have seen something similar in the Hidden Figures movie with the computers working on the computers with the punch cards. So was it similar to that?
Probably very similar.
Okay.
Very similar, right. So, and knowing that technology as we had at that time frame, our computer center had about 300 reel-to-reel tape decks on 2 floors. And we thought that was current technology, and today that's in your iPhone and Apple Watches.
And everything. So, and you said, so the reel-to-reel, so transferring one tape to the other, so from one reel to the next,
right,
on 2 separate floors.
On 2 different floors.
Wow.
And our printout was probably 2 feet high, that we would have to start looking to find all of the errors. We then had to handwrite the corrections. Then the girls had to key punch them back in. Then they had to rerun the whole 20,000 deck, and then we had to do that in 4 iterations to get to about a 99% accuracy.
Wow. Okay.
Right.
So tell us something exciting that maybe you learned on the job or that you got to see too as part of it.
Well,
thank you, Miss.
The first stage was so unique and different. When you know, it had the big 5 engines on it. The interesting thing is being the old sugar beet factory floor and New Orleans area being under sea water, the concrete pads would float. And so our doing laser technology for alignment purposes, we found we had problems that because of the concrete floor floating because of water level tables being so high.
Okay, so you were using laser technology to do that then?
We had laser lineups. That was basically just strictly for dynamic alignment purposes.
So how did it feel, I guess, watching everything finally come to fruition and seeing the program take astronauts to the moon?
Well, after Boeing's contract was to build 12 vehicles. 10 flight vehicles and 2 static vehicles for test purposes. And after that, we had built, I believe, 5 or 6 of them. The need for people, that many people, and they started having layoffs. So they transferred me to the Cape, actually Kennedy Space Center, and where Boeing had the contract to launch the vehicles, but we had to bring the vehicles in, test them in the VAB building. So,
that sounds like a lot of work.
It was interesting because in transporting the first stage to Florida, it had to be by an air-conditioned, climate-controlled barge.
Oh, why the climate control?
Technology, instrumentation, wiring, the vehicle is designed at sea level for stresses, and metal will expand in heat and contract in cold, and so they had to do it in a climate-controlled condition.
That makes sense.
Right.
Although I'd be concerned thinking about, having to get off the planet into space, and then I know we're thinking about bringing everybody back. So climate, that temperature has a huge effect on the whole program.
Very, very much so. So when they brought the individual vehicles from the first, second, and third stages, they bring them in and stack them in one of the 4 bays of the VAB building. So we had 4 vehicles in different stages of completion. So as one rolled to the pad, then probably bay 2 was getting ready, bay 3 was, and 4 was probably empty or just starting to be filled.
Oh, okay.
So it was a sequential type of thing. John? So in the end...
so sorry. Hey, you made it up.
Good. So in the end...
Fans,
it was interesting in the testing and the launching of the vehicle. Now, the crawler transporter was... The electricity generated by that would probably provide for housing somewhere over 10,000 homes. That's
a lot.
But it needed so much power because of the vehicle just to run it. It was basically an electrical vehicle. The pad that sits on, that it goes and picks up was the size of 3 football fields.
That's really big.
Side to side.
Okay.
And of course the tower was over 400 feet high when you go up to the very top. So when you put it on top of the crawler transporter and you put it on the pad, you're up 500 plus feet in the air.
Right now in Washington, D.C., they have the Saturn V projection mapped onto the Washington Monument.
Yeah,
that's the full size, the real size to get a sense of it, right?
But the top of the what they call the cue ball on the top was almost at the very top of the Washington Monument. Yeah.
Wow. So I mean that's a really big piece of equipment.
Right.
To think about strapping someone onto it and launch them is terrifying.
When they would take the vehicle out to the pad, they had the tracks, were so wide, and they had to run on gravel because the weight was so they couldn't do asphalt. So they had about 8 feet of gravel, and so when the crawler transporter with the vehicle on it would go through, it would crush over a foot down, and so they had, every time the one went out, they had to re-put
more gravel
in the pathway.
Fill it in, just like anytime you're gonna, here in our front yards, when you have to dig something out, you gotta fill it back in. Okay, same idea.
And the other interesting thing is when you watch the launch, if you notice all of the white stuff falling off the vehicle,
I've seen that.
That's ice, because the fuel is below freezing level when it's put in. It had 4 to 6 inches of ice, and so as it was shaking, that was all ice.
All the ice is falling off. And for the audience, what type of fuel did the rocket use?
I believe, if I remember right, it was LOX, LH2, and RP1 fuels, I believe, were the 2 fuels that we used. Yeah.
I don't know what that means.
Well, one's like kerosene, and one's like aircraft fuel.
Okay.
Right. And when the 2 mix, they're volatile. Right.
That makes sense. And it makes sense that they're very cold. To be a liquid, usually liquid form, right? To be nice and cold.
Right.
Wow, so lots of ice.
Right.
Okay. Well, there's so many aspects of this. And having worked on this program, what are some things that stand out that maybe you've seen in your career that you learned that you've taken with you, or that you think have just really made a difference?
Well, on the very first launch, the closest you could be to the vehicle was about 3 miles. The pad was a little over 3 miles away. So we were all standing in front of the VAB building watching. So upon ignition, with having the big flame deflector down the bottom, creates that tremendous plume of smoke and going that direction. The other direction was like a vacuum, and it sucked in every little rock and pebble and stick and weed. And the wind was slightly blowing our directions, and we were being pelted by little stones and because nobody thought about the vacuuming effect
Right.
that would happen.
So hence that real need, of course, for that 3-mile radius, huh?
Right. Well, just around the pad itself, not the
Okay.
whole 3 miles, just within the pad perimeter area
So
there.
there was no one in there cleaning anything out ahead of time. But
No.
Have we learned?
Well,
since
we
then?
didn't know that. So on the second launch, yes, there it was as clean as this floor.
Nice. Now, earlier you had mentioned that you didn't happen to be near the launch when it happened. You were in Washington, I think you said, for.
Well, on the Apollo 11.
The Apollo 11
right.
launch.
We had already launched 3 vehicles, and at that time they were starting to cut back the workforce because they didn't need everybody there. So Boeing had transferred me back to Everett, Washington on the 747 airplane. And that was where we put out 1 aircraft every 3rd day. 3rd shift of the 3rd day, 1 aircraft went out of the building to across the street to the paint hangar. But I was in the mall parking lot when they were just ready to land, and so I sat in the car and waited until, and I was looking up at the moon when I said, "We have touchdown," and all of a sudden all the cars, the horns honked and the lights came on. I didn't know anybody was watching, but the whole parking lot in Washington, city of Seattle was watching.
Was the whole
Right.
launch. That had to have been really
Right.
exciting. And now, did you get a chance then to watch the landing?
Oh yeah, right, yeah. No, I did. I watched the landing and everything. So.
And you remember where you were and how
Oh
you
yeah.
felt?
Oh yeah.
Was it exciting?
Well, yes, because it was so new, and it was so hard to comprehend. We were 250,000 miles away landing and communicating almost directly. The time span difference was like 9 or 10 seconds from the moon to there for transmission thing. So.
Wow. And now, so we'll wrap up our interview here. Is there anything maybe you want to tell people about something you think has been spectacular, or your hopes for the future, having worked on the Apollo program and then looking forward?
Well, we went from the Saturn program to then the space vehicle and the shuttle. And we're going back to the moon. We're out going to Mars. We've landed on satellites. We don't know what's going to happen next. It's just so dynamic and changing. So.
And that makes us really excited here at the Science Center because we get to help inspire that next generation that hopefully will take the next giant leap. So thank you for sitting down with me today, and thank you for sharing your story with us. Thank you for all the work you've done. It's engineers like you that really made a difference. So
I appreciate it. Thank you.
And thank you for continuing to volunteer with us too. So thank you. And thank you all for joining me and for watching us today. Everett Greenli, former Boeing engineer and former worker on the Apollo program. We hope you catch us next time. Find more information on Arizona Science Center at azscience.org. Take care, guys.
And a STEM advocate.